Okay, good. Let's actually get started over here, okay? So last time we talked about the graphic and you guys work on the Mickey Mouse and maybe Smiley. You can send to me by email, okay? If you finish it and if it take more time, okay? I don't want to rush you. So it actually, you can continue to do that. But today we need to move on to chapter 4, object and graph. Object and graph. So this one, I'm going to talk about the compound data today. Okay, compound data today. So what is compound data? So here, let me actually bring up my idle. I mean, I can use idle, I can use Visual Studio Code, and I can also use PyCharm. At this moment, because we are dealing with only one file, so I use only the idle. But when we need to do multiple file, we will switch to PyCharm, okay? At this moment, I don't want you to ask for trouble to actually have that problem. Here I'm installing Qt, okay? Qt is actually called Qt. Qt is a package for GUI, okay? Graphic User Interface, okay? And then your Python also have PyQt. It's a Python version of the Qt, okay? So Python also have PyQt, but we probably don't have time to cover this one. But this PyQt can help you to develop a game, develop a cell phone interface, develop a lot of things. But right now we are teaching Python programming essential, that's Python 1, and Python Qt, probably Python 3 or Python 4, okay? So it's not really that easy, okay? But I'm installing the Qt. This one is not the Python Qt, I'm installing C++ Qt, okay? Okay, let's go back to the idle part. I bring up the idle, but I do not see the idle go up. Let me try one more time. Let me see, something wrong with the idle. Okay, it's up now this time. Oh, actually, it's slow in reaction, so I actually invoke multi-core then, okay? No problem. Let me actually start to teach you the compound data, okay? Compound data. So compound data, let's see here, compound data. Before we go over to more things that actually look at compound data. What is compound data? Data can be only a single data, right? Single data, we talk about it so far. We have numbers, right? We have numbers. It's not good. Let me clean it, okay? So we have number, right? We have number. And number, we have integer and floating point, right? And then we have text. And text, we call it string, okay? So string, you use a single quote, double quote, okay? And then we have Boolean, right? Boolean is true or false. You have true or false, okay? F, capital F, F-A-L-S-E, okay? No good, so these are the single data. We call it scalar. Okay, we call it scalar. So scalar is A, right? And you can times 3, that's scalar. You can scale up, scale down, okay? That's the only thing you can do for the scalar. So scalar is a single data. 3, single number, that's a scalar. And then your A, that's a scalar. X equals 3, that's a scalar. As a single data, we call it scalar, right? And we can also call it a variable or call it an ID or whatever. There are several different names. Now we are going to talk about compound data. So compound data. And we haven't talked about compound data so far. So compound data, what is compound data? Compound data, we call it vector. Okay, we call it vector. And vector actually is like a point. A point is a vector. A point, you have X and Y, that's a vector, right? So you have a coordinate, and you have X and Y. You have one point called 1, 1. Start from here, one box, here, one box, here, your locations right here called 1, 1. Your original point is 0, 0, okay? So these are vector. And for Helen, are you okay with vector so far? When I talk about this two data combo, are you okay? I don't think fourth grader will teach this. You are fifth grader, right?
I don't know what vector is.
You don't know what vector is. So a single data is like A equals 3. That's a single data, right? A vector can be a point, but it's 3 and 4. Like actually it's the address, let's say a point. Is that okay? Is that okay?
Okay, so like
that is a point. A point is something like this. A point is like something like this. You have X and Y, right? And you have
and X is first and Y.
Yeah. So right here, so for example, like your home is over here, right? There's a library, right? You go east 1 mile and north 1 mile. You go to 1, 1 point. That actually is a location, right? You can say some other people's home is located as 3 miles east, 4 miles north. Is that okay? And that's a location, that's a point, and we can also call this one as vector, okay? And this one in Python, we really call it a tuple. And this one, the single data, we call it a scalar or a let's call it this way. Let's call it a variable, okay? And it can be called a scalar, okay? And this one is a tuple. So you can have a tuple like this. You can also have point, but actually a point in 3D, right? 3 dimension. You can have 1, 1, 1, right? 3 dimension point. Okay, so this one is a 3 dimensional point. All of the space need to have a 3 dimensional point, right? This one is also a point, and it is actually a vector, and it also is a point. It also is a 3D vector, okay? It also is a 3D tuple, okay? So that actually is a point. Can we do point 10D? Can we do this? Yes, the answer is yes, okay? We can do that. As for the meaning, I don't know. I don't know what is the meaning, but we actually can do this one. And this one with parentheses, we call it a tuple. We call it a tuple, okay? So tuple is a group of data that put 2 integers in there. We call it a tuple. 2 floating point in there, that's a tuple, okay? So that is a tuple. So the second one I'm going to talk about is a list. So a list equals 1, 2, 3, 4, 5, 6, 7. This a list is different from the tuple. Okay, so this one is a 7-element list. Okay.
Doctor?
Yes.
What is a tuple?
Tuple is a tuple is a value. So here we can say this one is a 2 tuple vector. 2 tuple vector.
So
okay. So this one is 1 tuple. Okay. And the whole data we can also call it a tuple. So,
okay.
So 2, 3, 4 we can also call it a tuple. The data type is called tuple, but actually you can call each individual one a tuple as well. Okay, so you can call this one is a 3 tuple actually.
Oh, 3 tuple.
The data type is called tuple because the Python language call it tuple.
Okay.
Okay, Python language call it tuple, but actually each single one we call it a tuple.
Okay. So there's
Is
three
that okay?
tuples. Three
It's a little
tuples.
bit confusing here. Okay, so
Yeah.
single data is a tuple, and the whole data type is also called a tuple.
Full data type is also called tuple.
Okay, both are called tuple, but original name for the original meaning for the tuple is a single data field. We call it a tuple. Is that okay? So we can say we can type Python tuple. You'll find Python tuples. You'll find Python definition for tuples. So you can put this tuple apple, banana, cherry. Is that okay? So this one is a 3 tuple, 3 string tuple. Is that okay?
Yeah. Thank you.
So this three tuple is apple, banana, cherry, and we can print it. And we got this one. Is that okay? So if we change it to not using apple, banana, whatever, let's try 1, 2, 3. That's also a tuple. You can run it. It is still a tuple. You can put even this is a tuple. You can do like Eric Chow, right? And 800, 790, 800. Okay, SAT score. That's also a tuple. 4 tuple, 1 string, 3 number. That's also a tuple. So a tuple is an association of data that you put data together. So 3 integer and 1 string, that's fine. That's actually can form a tuple. Is that okay? So tuple because it is the name of the data type called tuple. Python call this one tuple. It's an ordered, unchangeable data. Okay, tuple is a collection which is ordered and unchangeable. You cannot modify the data. Once you assign it, it will be something like that. Is that okay?
Yep.
But you actually can do like print. This one's called this tuples index 0 tuple. Index 0 tuple would be this string. Okay, and that's wrong. Is that okay? Is that okay?
Yep.
Yeah.
Wait.
So if I try print this tuple, and let me try 2. 2 will be 790. 0, 1, 2. Here you have the index starting from 0. So here this index 0, index 1, index 2, index 3. So I'm going to actually run this one. You print out tuple 0 and tuple 2. And it is 790. Is that okay? Is that okay? So, yeah, question? Hi, question?
Nope. Thank you.
So a tuple is a Python name, but unfortunately, 3 tuple vector is also okay. So the tuple actually is a single data is called a tuple. So n tuple vector means that they have n data. So you can have 2 tuple, 3 tuple. 2 tuple means 2 and 0. 3 tuple means -1, 9, and 7. And tuple means single data field, but that's the original definition. Okay, so you have Cartesian point in your Cartesian space. That's a 3 minus 1. That's 2 tuple data in 2D domain, right? But that name tuple original is defined in math as a single data field. So you may have a point with 3 and -1. That's called 2 tuple. Okay, 2 tuple. And then you may have 3 tuple 3D vector, right? But unfortunately, the Python also call the whole data collection as tuple. Is that okay? So tuple originally means a single data field called tuple. So you can have 2 tuple vector, 3 tuple vector, but somehow Python also call the whole thing as tuple. Okay, any question?
No, thank you.
So that one actually is by parentheses, and you cannot change the data. You cannot change the data, but you use a parenthesis, and you can have two tuple, 3 tuple, and 10 tuple. Okay. Now, second one I'm talking about list, and this is different from tuple. This you can print. You can print a list. Okay, and then you can say a list 0. I change it to 10, and I print it again. I talk about the tuple you cannot change, not unchangeable. But here you actually can change. Okay. So here you actually can change. Okay. So here, let me see. I'll save. So the second data type I talk about right here is called tuple. Vector. Okay, I'm sorry, vector. So here, let me choose a different directory. I'm going to put it in part 2, so I don't mix up with the Mickey Mouse data. Okay. So let me create a new folder. Okay. Sorry, it's a little bit late. I'm sorry. That's a while. I don't know why. Okay, let me try one more time. Okay. So here, let me do chapter 4 P2. Okay. So part 2, chapter 4, part 2. And let me put it over here. Let's call it compound data type. Okay. So this one, the first one got changed. And I say tuple you cannot change. This one you can change. Okay. And you can also do for each x in a list. So a list is iterable. You can think about this iterable as a countable. So you can count the scenes, and every time I put now every x in the a list, and I run it, and I print now each individual one in the a list. Okay, each individual one in the a list. And here I can also try to have R list generating from list of the range function. So my range function, I started from -1 to 12, each time increased by 3. And then I print my R list. So range function is a generating function that will generate a tuple range list, and you convert it to list, then you can actually, okay, it only -3. Let's look at it. Okay. Step size here, let me try to change to 12. Okay. So it generates from -1 plus 3, it becomes 2, plus 3 become 5, plus 3 become 8, plus 3 become 11, and then plus 3 become 14. 14 is out of the range of 12. Is okay? So 14 not included. You end up this is this generated by the range function. Is okay?
1 second.
Does that make sense? The range function is a list generator. Okay? Make sense? So if I want to generate 1 to 10, so 10 list equals list of range from 1 to 10, but I need to put 11 because 11 not included. Every time I increase by 1, then I don't need that. And then I print 10 list. So So here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is that okay so far? Let me put this one on here.
Go back to the code.
Yeah, it's like this. Is it okay? Let me put it like this. Any question? So a single data is called a scalar, right? Two tuple data can be a list, can be a tuple. Tuple means you cannot change the data content. List you can actually change the contents. Okay? And then you can use range function to generate a list. And you convert it to list. Range function will generate a range object, but you need to use a list to convert it to list. Then it will become a list. Ethan, are you okay?
Okay.
Yeah.
You okay with what I'm talking about so far? So today we are moving on to the compound data. I haven't touched the object yet, but I want to talk about the compound data first, okay? First one, yeah, question?
So for the R list, that just it randomly generates numbers between -1, 12, and 3. I don't really understand like what the R list.
The range function has 3 numbers over here: starting number, ending number, and step size. So it started from -1, step size 3. Every time plus 3, you go to 2, right? Then plus 3, you go to 5. Then plus 2, you go to 8. Then plus 3, you go to 11. Then plus 3, you go to 14. But 14 bigger than 12, so 14 not included. You end up with -1, 2, 5, 8, and 11. Is that okay?
Yeah, thank you.
So let's try another thing. Here, if I have a range function, my range function starting from 1, and I put nothing. This one actually, if there's only one number, it actually means an ending number. So it actually will be starting from 0, ending at 1, 1 not included, step size 1. So this one, range 1, equivalent to range 0, 1, 1. This single value, that means the ending value. Okay, it will start from 0 and end at step size 1. So this one, it actually will generate a single data list, only a 0 in there. Is that okay?
Yeah.
Yep, thank you.
Make sense?
Yeah.
So let's assume that here, if I have a, let me just print it, okay? Let me just print it. So let me just print it. So let's do this one. Actually, R1 equals list of, let me see, range of 1, 3. Okay, let me do this one. Okay, let me try to do this one. Print. Okay, let me try to give you explanation. Okay, so let me do this one. Range 3. Okay, I put an equal sign, comma, and then I print R1, right? So let me give you more information. So it's a single data. I print range 3. So you print out 0, 1, 2. Okay. So here I have a range. I starting from 3 up to 13, each time 2. And this one I call it R2. Okay, and this R2 will be 3, comma 13, and then 2. I'm going to print out this R2. I'll try several of these kind of range function. So, and use range function to generate list. So you will know different list you can actually have, okay? So let me try to have R3. So R3, let's try 2 number list. So 3 to 7. 3 to 7, let me see, 3 to 7. And this one, let me print out R3, okay? Last one, let me actually do 10 down to 3, each time -1. So this one, let's do 10 down to 3, each time minus 1. So that's 3 number. This one is called R4, range 4 function. Okay, good. That's wrong. Okay. Okay, so let's see. First one, we have range 3. Range 3, single number. So we started from 0. So range 3 really means range 0, 3, 1. Okay, if you don't give the third number, it will be 1. First number will be this number. If 2 number will be this one and this one. Okay, 3 number would be this 3. So if there's only 2, if it is only 1, it actually is this 3. So this range 3 equal to range 0, 3, 1. It will start from 0, ending at 3, 3 not included, so you end up with 0, 1, 2. Okay. Second one, starting from 3, ending at 13, 13 not included. Every time increase by 2. So it will be 3, 5, 7, 9, 11, 13, but 13 not included, so you end up with this one. Is that okay? 3, 7, 3, 7 means 3, 7, 1. So you'll be starting from 3, 4, 5, 6, 9 including 7. So 7, 9 included. You end up with this. Is that okay? Then the last one, range 10, 3, minus 1. 10, 3, minus 1 means that starting from 10 down to 3, every time count down by 1. Okay, so it will be 10, 9, 8, 7, 6, 4, 6, 5, 4, 3 not included. So actually end up with this. Is that okay?
Yeah. So this is like sequence or like series.
Sequence generation function. Yes, sequence generation function. Okay. Sequence generation function. Yes. Okay. So this one, let me put it as my compound. So compound good. Okay. I'm going to save as compound 2. Okay. Compound 2. Okay, so this is the list. So now let me actually delete everything here, right? I have the in the compound 1. Now let me look at compound 2. So yeah, it actually is a generating function, right? How about how can I generate a even numbers? And actually that is actually from 0 to 20. But I say 22 every time, jump by 2. Is that okay? So this one print actually even in 0 and 22 in this range. Okay, all the even number in this range. And I say this is even. Okay. So starting from 0, ending at 20. 22, but 22 not included. So actually this one is starting from 0 up to 20, 20 included. Okay, 22 not included, 20 included. So this one is a generation function like this. But you can also do down counting. Down counting, you can have this even put down to here. Let's put even 1. I say from 20 down to 0. 0 not included, so I need to do -1 or -2. Each time I do -2. And then this one, let me cut print. You do down counting. So you see, even starting from 20 down to 0, not including 0. So I put a -1 there. It will be greater than -1. So something like this. Okay. Any question so far?
Could you go back to the code, please?
Could you go back to the codes?
Doing okay?
Yeah.
Yeah. Ethan, are you okay?
Yeah.
Must remember this, okay? I'm teaching in very much details. Okay, these are actually lists, and I use arrangement. Can I try different way to do this? Yes, you can try different way to do this, okay? I can actually do this one called even 2. Okay, even 2, I can do 2 times I, right? For all I in range in this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? I can do this one. For all 2I, the I actually in this, actually, this is actually legal. Okay. So let me print out this guy. So this one is from 0.
Dr. Chow,
Yes.
why is there like double parentheses, like double brackets? What do double brackets mean?
Yeah, you will know later. Okay, don't worry. Let's run it first. Is it okay? It generates the same thing as even, right? So here, this one is a list. So every time I got an I from this list. So first I is I what? I equals 1. I0 is actually I equals 1. So 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 5. Is it okay? This kind of list, we call it comprehension list. Okay? And I can also type even 3 equals 2 times I for I in range actually what? 0 to 11. Okay, so I say to 11. Not including 10, right? So this one would generate the same thing we want to have. This is called comprehension list. Oh, the first one don't have 0. So here, let me starting from 1. Okay. To match the previous one. I don't want it to be different. Is it okay? So this one actually is 2I. What kind of 2I am I going to generate? It's an I from 1 to 11, not including 11. So I will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm going to make a list called 2I. So this one, you can do this one. If you learn the math, there is something called set, right? So you're writing a set, you can say this one actually is 1, 2, 3, 4, 5. That's a set by listing, right? Listing the data. There is another one of way to do is like X, right? And then actually say X belong to even number. And also X actually greater equal 0, X less than 20 equals to 20. So this is called what? Comprehension listing of the set.
Wait, but doesn't 2I mean you multiply the range by 2?
Multiply I by 2.
Oh, okay.
And for each I in this guy.
Okay.
Is that okay? So range will generate some sort of a set, some sort of data, and every time you get one. So how about this? Can we do this one? Can we do even 4? And then let's do 2, 3 times I, right? For each I in, this time I'm not going to do list. How about let me do 3, 4, 5 in tuple. Can I do that? I'm using tuple to generate. Can I do that? So here let's do actually.
Yeah, you can do tuple, right? Because tuple is just like a collection.
It's like a
list.
set. Yeah. Okay. So something like called iterable or something called countable or something like a set can be put over there. Is that okay? So this list is somewhat like a set. tuple is also like a set, some membership. Tuple actually you cannot change the data. List you can change the data, and list you can generate by range. And you can also put this differentiation over here to generate your set, your list. Is that okay? Any question?
No.
Could you
This
please
one-
wait for a second?
Yeah, no problem. I can wait. This is called
Thank you.
comprehension list, okay? So this kind of compound data is like a set. A set is non-recurring. Here you are recurring. List is recurring. Tuple is recurring because some point you will have x, y, that's 1, 1, that's 2, 2, that's 10, 10. So it's recurring data is okay here, okay? And list is something you can change the data. And this can also work like an array in our language, okay? I'm not going to talk about the array yet, okay? But I just give you the idea of what is a list. And you can use for loop with the list, right? You can use a for loop for each list. So sometimes we call this guy for each loop, okay? So for every e in even 4, every even number in even number set 4. Is that okay? We can print that actually you see this one is called for each loop. For each loop. For each what? For each even number e in even list. Even 4. Is that okay? This guy is called for each loop. For each e, for what e? E in even 4. What is even 4? Even 4 is generated by this comprehension list. It's a 3i. What I? I is from 3, 4, 5. And for each of these even number, okay, it's not even number, okay, actually I messed up, but let's call it e, okay? So actually that e, I'm going to print it. That e, I'm going to print it, okay? For each e number in even 4, I'm going to print it. Okay, so you print now 9, 12, and 15, okay? Any question up to here?
No question. Thank you.
So here we are talking about how we create a collection of data, right? How we put it into unchangeable tuple, or we put it into changeable tuple, or we actually use a comprehension list to generate it, or we put that list into a for each loop, right? These are the combination of the things that we can do with the collection of data. And chapter 5, 6, 7, 8, 9. The whole 9 chapters are on these. Is that okay?
Wait, so that for e and even 4, that's a for loop, right?
That's a for loop for each loop.
Yeah.
For each entity, that's not calling it even. It's actually not even number. So let's call it entity. Is that okay?
Yeah, thank you.
Okay, so these are compound data. You need to learn this basic part, and when we go to more complicated things, you will actually know how to handle it. Okay? Any questions so far? So here I teach you one single number. I teach you parentheses. I teach you break it for list. I'm going to go to compound 3. Is that okay? Done here? Done? So that's actually create compound 3, okay? Compound 3, let me actually save us. So let's call compound 3, okay? Okay, I have compound 3. Now I'm going to work on compound 3. I learned about parentheses. I learned about parentheses. I learned about brackets. Now I'm going to learn about curly brace. Curly brace is called set. Okay, so this set is actually 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Actually 1, 2, 3, 4. Okay, whatever. I just try to create a crazy list using these different numbers. Okay, I just type multiple of them in here and finish that. I'm going to do print s. Okay, I put an example list for that set, but I actually end up with this. Got kicked out a lot of elements. What's that? Because this one curly brace means set. And set is non-recurring. No duplicate, no duplicate. Is that okay? Is that okay? Set.
Wait, I'm sorry.
What
What
are
is? Oh, sorry. Go ahead.
James, go first.
Okay, so what does the curly brackets mean?
Curly bracket means this guy.
Oh no, I know what they are, but like, what do they mean?
They mean set.
Okay, thank you.
Have you learned set so far?
I don't know what a set is.
You don't know what is set. How about Ethan? Have you learned set?
Didn't we do that in Mickey like set off bill?
Yeah, so you know a little bit. That's what you mean?
We all did it in the Mickey thing.
Okay. How about Helen? Have you learned set?
I don't think so. No.
You never learned set, okay? So set, what is set? Set, we say n. Natural number is a set. Natural number n is a set. So Helen, what's the natural number?
Like a whole number?
Whole number. Natural number is different from whole number. Different. Whole number is -1, -2, -3, 0, 1, 2, 3. So whole number is actually plus, minus, and 0. All okay. Natural number can only be positive. So natural number also called countable numbers. 1, 2, 3, 4, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Is that okay? Countable numbers called natural numbers. Is that okay? So that's a set. So it actually from 1 to infinity, right? We don't know how big it is, but any number that actually countable, we call it a natural number. So in the nature, there's no zero watermelon, right? There's no such thing as zero watermelon. 1 watermelon is 1 watermelon, right? That's countable. That's natural. So 0 is a concept invented by people, right? And -1, you borrow me 1 melon. That's because I actually borrow 1 from you, and you lend me 1. So actually, I have -1 melon. Actually, I got 1 melon, but I need to return it to you. So the people invented the concept of -1. But -1 is a conceptual one. It's not a real one, because in reality, I get 1 watermelon from you, right? Is that okay? Hello? Helen, is that okay?
Yeah.
So in natural world, you can only use a natural number. There's no such thing as whole number. There's no such thing as fractional number. There's no such thing as anything else. Even if you go to the chemistry, right? You go into the chemistry, you have atom, you have electron. Even atom, electron are countable. You don't have 4.5 atom. No, there's no such thing as 4.5 atom. There's no such thing. Everything is a natural number countable, right? You say 4.5, that's conceptual. That's not natural number. So natural number n is a set. Whole number integer is a set. Rational number is a set. Rational number is some number you can represent by two natural number or two integer number. That's a rational number. Then real number is anything you can actually operate by real functions. Okay, these are different sets. And rational number, you have a watermelon. I say it's a half watermelon because I cut a slice. Use a knife to cut it into half. One half here, one half here. That's conceptual. You can call it two slices, right? You can call it two slices. It's you that say that I have two slices, and I count one slice this side, one slice this side. So that's two slices become one half watermelon, one half watermelon. But the 1/2 is also conceptual. It's not natural. It's a man-made number. Is that okay? We call it man-made number.
Wait, 1/2 is just half. Why is that man-made?
It's a man-made number.
Really?
Yeah,
Oh.
because there are two slices. So
Yeah.
so we call natural because it's natural, no artificial, right? Natural number is real natural number. Is that okay?
Oh, okay. Yeah, it's just
Anything not natural is artificial, right? People
Yeah.
who do plastic surgery, that's actually not natural, right? Even if some girl won the world beauty contest, not natural is not natural, right? Well, they can win the champion, but it's not natural. It's not natural. Okay. Anyway, natural means something you can really see it one by one. So you can say I have 5 stones, right? And I got stolen by my neighbor by 2 thieves. 2 thieves got stolen by my friend. But actually, you lose 2 stones, actually. Is that okay? Is that okay? The natural number is something countable, something you actually do that. Okay, that's actually is a set. So set is a collection of data, but you do not allow it to basically duplicate. So I can have some set called M2 10. M2 10 means even number, multiple of 2 starting from 0 and 2, 6, 4, 6, 8. That's actually multiple of 2 and below 10. Is that okay? That's one set. So I can do multiple of 5 actually below 10, right? And I will end up with 0, 5, right? So how about I change this one to actually 20. Okay, 20 is a bigger. So 10, 12, 14, 16, 18, right? 9 include 20, 9 including 20, okay? I promise to be below, so below 20. So this one, I have this one, 10 and 15. Okay, I generate these 2, okay? One is multiple of 2, one is multiple of 5, and then I actually have this 2 set, right? So first thing I will do is union. So U M2 M5 equals M2 underline 20 plus M5 underline 20, and print my U M2 M5. That's called union. See, there's no such thing as plus. I'm sorry, union is not square. Union is single or. Okay, let me start. I'm sorry. It's actually single. Let me try one more time. Okay, sorry for this. Yeah, it's a single or bar. Single bar, we call it union. Is that okay? So union, you have the multiple of 2 and multiple of 5 putting together, that's called union. Is that okay? So we have a set, multiple of 2 over here, M2 over here, multiple of 5 over here. Multiple of 5, you have 0, 5, 10, 15, right? 0, no, 0 is not here. You have 2, 4, 6, 8, 12, 14, 16, 18. So multiple of 2 is this, including 0 and 10. That actually is this one. And multiple of 5 actually is this one. Okay? And then you have the union. Union actually is the union is usually a single bar. Single bar is union. Yellow one's union. You use a single bar. Single bar also means or in logic. Okay, so single bar is union. Is that okay? Union. And this one we call it Venn diagram. So I think Zoe know this one, right? Zoe, you know this one, right? Venn diagram and this math. But I don't think others may know. Hi, James, you know this one? Venn diagram and this union and whatever?
I don't really get it.
You never learned this before.
I know what a Venn diagram is, but I don't understand what this is trying to show.
This part is multiple of 5, right?
Yeah, that's multiple of 5. I get that.
Yeah, multiple of 5, you have 0, 5, 10, 15. That's multiple of 5 below 20, right?
Yeah.
And the other,
so this is even numbers, and those are multiples of 5, and from both of those we can figure out O and
yeah.
Got it. Thank you. Oh wait, also, what is that? Why do we have that single bar again? Why do we use that again?
It's actually called union.
Union. Okay.
Union is the two set counting all the member in both set, but no duplicate. So actually, you originally have at multiple of 2, you have 0, 2, 4, 6, 8, 10, 12, 14, 16, 18. And multiple of 5, you have 0, 5, 10, 15. So you end up with the union that is over here. You end up with the union that here. 0, 2, 4, 5. 5 is from M5. 6, 8, 10. 10 is from U5 and also from U2, M2. Yeah, okay?
Yep. Thank you.
Okay. Ethan, are you okay?
Yeah.
Yeah? You are okay? You learned this before or no?
I don't think so.
You don't think so? Okay. So look like you guys need to learn some set theory, okay? Easy set theory. Usually school did not teach this well. You can learn this one from AOPS usually, okay? Set theory is an important MCA topic, okay? Now let's look at the intersect. Intersect is this portion called intersect. The member that happen on M5 and also in M2, that's called intersect. Okay, so we will end up to have 0 and 10. So here we do intersect is I intersect. Union is UNI. Union means UNION. Sometimes you have set M2, you can write U and 5. Okay, that's union. You can also write this in Python. Python uses a single bar. Okay, that's union. Intersect. Intersection, we do M2 overturn U for intersect, and then you
Yeah, I remember doing this stuff, I think,
yeah,
in 10th or 11th grade.
really.
I think so. Or maybe Ethan, stop, sorry. But maybe, I don't know. But
I
it was a
think
long time ago.
I think at least before
Oh, wait,
pre-calculus.
wait.
Yeah.
Wait, I know. Yeah, it's pre-calculus. It was like 10th grade. And then, yeah, you have that union. Or no, actually, no, wait. We also did this before.
I
Never
think
mind.
seventh
I
grade.
think,
Seventh
no, you're right. 7th, 8th grade. When you're
Yeah.
doing the points, like different points, and you have to like combine 2 points,
Yeah.
union. Or
So you tell Ethan if he learn algebra 1, he should learn this. Okay. That's something he need to review. I mean, algebra 1 should include this one. Okay. Well, if he hasn't learned this one, it's actually not. It's okay because he's not really that old. Okay, so no problem. But you can go to Khan Academy. Same thing. There are union of set, intersect of set. Okay. There's a whole set theory in Khan Academy. And I believe this one is somewhere like 6th, 7th grade should actually learn this one. Okay? 6th or 7th grade should learn this one. Okay? And if you want to compete in AMC 8, okay, I believe that maybe Ethan and James both are interested in that. You should go there. It's math, probability, statistics, actually basic set operation. Is okay? This quotient, you need that. I mean, even though it's not in your high school or middle school, but it actually is important because you will need it for AMCA, okay? And some school teach it in algebra 2, some teach in algebra 1, some teach in geometry, some never teach, okay? Some wait until math 2 in SAT to study. But anyway, I would say pick up early would be good for you, okay? So if you don't know, it's okay, it's natural. I know that most high school or middle school, they did not teach it, okay? They did not teach it. So it's nothing wrong if you don't know about it or know about it but not really firm about what it is, okay? So this one intersect, I use an X sign, that's end. And I can print out my intersect of N2, N5. Okay, so this one is wrong, this one. So there is one operator called or union. There's another operator called intersect. So intersect of the multiple of 2 set and multiple of 5 set is only 0 and 10. Is that okay? Is that okay? And we can do Boolean BO, okay, equals 5 in M2, okay? And then we do print phi in M2 is comma Boolean operation, okay? Oh, I'm sorry, not M2, M2 underline 20, okay? Sorry. Yeah, it's false. So this one is testing you. Test if phi is a member of multiple of 2 set. Okay? And remember that our for loop has what? Our for loop has for each I in multiple of 2, 20, right? Something like that. Right? So this in sometimes is picking one member from the set, or it actually is testing whether that is in that set or not. Is that okay? Make sense?
Yeah.
Yeah? Okay, so there are a lot of things to learn, okay? There are other things to learn. And if you want to be an advanced student and say someday go to name-brand school like Stanford or Harvard, you're probably not going to spend too much time in game, okay? It will not lead you to those schools. Okay, any questions so far up to here? These are sets. So set, you have intersect, you have union. You can get every member, test member in there, okay? And next one, let's try something called difference of the set. What is difference? Difference means, let's go back to our Venn diagram. Venn diagram, we have 0, oh no, 0 is not here. Create, okay? 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, okay? And we have multiple 5. 0, 5, 10, 15, okay? So that's multiple 2, multiple 5, okay? So the union, we use yellow, so we know about union. Union is this one, so union is M2 bar M5, okay? This is called OR, okay? Single OR bar. And we have M2, I'm sorry. We have M2 and the M5. This one is called AND and it actually is called intersection. That actually is this part, right? Another one is called M2 minus M5 using minus sign. That's in M2 but not in M5, so that's the blue one here. That's called difference. So it's the member in M2 but not in M5. So here, let's see. We have diff 2 to 5, okay, diff 2 to 5. So this one's M2 underline 20 minus M2 underline 5. I'm sorry, M5 underline 20, okay? Print my diff 2 underline 5, okay? That's the difference between multiple 2 and multiple 5. Okay, here we have diff 5 and 2, okay? 5 and 2, that actually is in set 5 but not in set 2. Diff 5 and 2, so that's the set 5 minus set 2. Set 5 minus set 2 will give you this pink one over here, okay? And that's wrong, okay? So this part I'm talking about is kind of like partly math, partly computer, okay? Any question?
Can you go back to the code, please?
Yes. Let me clean it. This portion, the Venn diagram, okay, right? Let me put the code only, okay? Over here, okay? Any question? We are going to do real one, okay? Real example. So who is going to use this set? When are we going to use set, okay? So this one, I'm going to save it as compound 4, okay? Okay, who is going to use the set? Let's assume that we have some people, okay? So Apple, Brian, okay? C, Cairo, right? D, Daniel, E, Evan, F, Frank, okay? G, George. Okay, let's assume that we have these 7 different people, okay? These are the 7 people we are talking about, okay? So we may have a set called rich, okay? So rich people, we have, let's say we have Abel is rich. Okay. Daniel is rich. Okay. Frank is rich.
Wait, I have a random question.
Yes.
Why didn't you add Ethan for E?
What?
Wait,
Even.
why Ethan?
Where is
Yay.
Ethan?
Sorry.
Oh, okay.
It's not related.
Good suggestion, actually. But he may not qualify, actually. Rich. He qualify? No, kidding. Is Ethan rich? Okay. Then the other one is actually called handsome. Okay. So handsome boy, here we have, say we have Brian. We have Cairo. We have Daniel. Okay. Okay. Let's also have even. Okay. So let's assume that here we have two lists. One is rich and one is handsome, right? Now let's see. Okay. Now I'm going to actually try to pick a set. So here is good boyfriend. My good boyfriend standard is actually need to be both rich and handsome, right? So I would say that would be the intersect of the rich and handsome will be my candidate for good boyfriend, right? Is that okay? Make sense? Right? That's N. So you actually need to be both rich and handsome. You're going to there. Now we have another set called work hard. Okay, this work hard set we have able. Okay, and then we have here we have Cairo. Okay, we have actually Daniel. Okay, so this is a working hard set. So here, this one we say Stanford. Stanford will admit people if you actually are rich or you are working hard. Right? So these are the typical application of the use for these sets. Okay? My example may be a bad example, but I'm just trying to come out with some calculation that you can use, okay? Okay, so that actually is why we actually need to do such calculation. So you can read the data from somewhere and determine whether they are rich or they are not rich, right? And you can determine this person is handsome or not handsome. And you can determine whether Stanford will admit you or not. If you are rich or you are working hard, you will get into the Stanford, right? And if you want to be a good boyfriend candidate for somebody, right, you have to be both rich and handsome, okay? A person who is rich but look ugly, and that's not a good boyfriend candidate. And a person who is handsome but poor, that also not a candidate. Is that okay? So these are the why sometimes people would use the and or operation, right? Is that okay? Hello, is that okay?
Yeah.
So here, if we have a function called Stanford the mean, right? We would check a person X. If that person is Stanford at the mean or not, we can just return what? We can return actually what? X in rich or work hard. right? Define is a good boyfriend. Define if this one is a good boyfriend, we should return X in, rich, and handsome. Okay, so here we do print. Here let's try Cairo, right? Try actually Stanford. At the print good boyfriend. Here actually the George. Okay, anyway, that's actually two function return Boolean value. So sometimes set will combine with the function, okay? Sometimes set will combine with function to do operation. Any question up to here? So today we cover 3 data structure, the simple scalar, vector, and tuple, and then list, and now set. Now we finish set, okay? Next one we are going to cover dictionary. So let me, okay so far? Okay so far? The set is not really hard, okay? But you do need to have good logic to operate it, okay? Any question? Ahead, and are you okay?
Yes.
Yes? Good. So if everybody okay, I'm going to try compound file, okay? So what else can we do? Next one, we call it map, or sometimes call it dictionary. And this one probably the most important data type, okay? So what is dictionary? A dictionary, as its name, it actually is dictionary equals, it's a bracket, curly brace, okay? And now it has something we call it key value pair with comma. Okay, I use a sharp is not needed, okay? So key value pair. So here you would have, say, here you should have, say, let's assume that this is a SAT score list. So Eric has 800, right? And then here we have this guy, Abel, actually is 760, okay? And then we have actually this guy, Brian, who is 680, okay? And we have Daniel, okay, whatever. I just try to make up a few names, okay? This one, 540. Okay, good. That's actually is my dictionary, and I can print the dictionary. Okay, so dictionary is a list of value key pair, key value pair. Okay, okay, you can print it out. So basically, what dictionary we write it down here is actually dictionary. Okay, we have dictionary, and then here you have key. Key usually is using string, okay, and value and comma. That's one tuple. Key value, key value, and then you close it with curly brace, okay? So that's actually is a dictionary. Why we call it dictionary? This is a dictionary term. This is dictionary definition, dictionary term, dictionary definition, dictionary term, dictionary definition, okay? And we can also call it map because one string, one name map to a score, one name map to a score. But in Python, we call it dictionary. In Java, we call it map. It's okay? Any question up to here? So this is called dictionary, okay? So dictionary is a collection of key value pair. And this is most important because Python, JavaScript, they all depend on it, okay? Any questions so far? So I create dictionary. Can I get all of my keys? Yes, you can get all of your key. Your key can be this one. Can I get my value? Yes, I can get my value, and I can get all my value by doing this. Is that okay? Can I get my items? Yes, you can get your items. You can do items. Okay, so that's print keys, comma key. Okay, print values, comma b. Okay, print items. Okay, comma items. Okay, so that's run. Yeah, so what happened? What happened is this actually, they give you the dictionary key, dictionary value, that's the class name, okay? So I actually would like to actually make them as list, so it will be easier. So let me actually put them into a list, okay? Let me convert it to list. Print now is a key type, but key type is not a general list. So I just put them as list. Yeah, it's okay. So what does this actually do?
Could you stay on the code for a second?
Yes. So what does this do? I'm sorry. Let me keep it there. Okay, sorry. Oh, up to here. So what does this do for us? The data is key value pair. The data is key value pair, right? And then we actually can get only the key. Only the key, we actually get the key. So our key is Eric, Abel, Brian, and Daniel. So it's a list of the names, right? And then the value, data value, you get all of the values. That's the SAT score. So it actually is a list of numbers, right? And item actually you get what? You get a list of tuples. And each tuple you have a name and a score. Name and a score, tuple. Is that okay? Any question?
No.
This we call it dictionary. And why I say dictionary is so important, I told you that it is used both by Python and JavaScript. So here, let's go here. Okay, if you are at the AP Computer Science Principle, I'm going to teach you this. Okay, so here actually you are here about blank. Okay, you give you a blank page and you actually can do inspect. And here you bring up the console on your Google Chrome. Okay, this one only works for Google Chrome. But let me pick the console. Okay, and inside this console, let me actually do the same thing. So here I have a D equals, I have Eric colon 800 comma Abel colon 760 comma Brian colon 680 comma Daniel colon 540 return. Okay. Okay, so I actually can do similar programming on my website for JavaScript. Okay, so that's why I told you this is extremely important because it's shared data structure between Python and JavaScript. Okay, any question? I'm not going to teach you too much JavaScript. It's another course, completely different course. But I just show you actually two can be compatible. Okay, so when your Python used for server side website construction, your JavaScript used for the client side computation. Okay, so now you're 6th grade, 7th grade, whatever. You are learning Python, and then later you will learn Java, and then you go for AP, CSA, and then you can also learn JavaScript, okay, and then HTML, and then you pick up AP, CSP, okay, and from this one you go to user code. From this one you go to hackathon. Okay, that's why your parent want you to learn computer, right? And then this one you compete for the gold medal and you become a computer science class president, right? That's the goal. Okay? And you are right here, okay? Work hard, okay? It's a long way to go, many years. But you need to pick up multiple languages, several languages. Okay? Any question up to here? So it's a key value pair. And we can do this one. We can do for each person in dictionary D, okay? Print out the person dictionaries person data, okay? That is legal. For each person in dictionary, print out the value of the dictionary person. Right? You print out every data.
Wait,
Okay.
so the point of the map or dictionary, that's just to sort information, right?
Yeah.
Okay.
So you can also print out a person and its value, okay? Is that okay so far?
Yeah.
So dictionary is some sort of database. It's as fundamental as database. Is that okay?
Yeah.
Got it? It is as fundamental as a database, okay? And in JavaScript, it actually is called object. It's not called dictionary. It's called object. JavaScript actually call this guy as object, okay? But this is very useful. I mean, extremely useful stuff. Okay, right here, I'm not trying to teach you all the programming detail for this different data. I just want to go through each data type, okay? And we just touch little part because we still have chapter 5, 6, 7, 8, 9, 10 to cover each individual data structure. So I'm going to just try over different data. So you know that we have different data type. And by what? By the parentheses, brackets, curly brace, key, column, value, comma, key, column, value, comma, right? Key, column, value, comma, and this. So remember this is what? Helen, what is the parent parenthesis what?
Parentheses?
Yeah. You put 1, 2, 3, what is called, what's the name of this data type? It's called tuple, okay?
Tuple, yeah.
How about brackets? How about brackets? Bracket called list, okay, remember?
Uh-huh.
How about curly brace?
A set.
Is a set. How about this one? Curly brace inside your key value pair.
Set number 2.
It's called dictionary, okay? Okay, here you just need to remember the notation and the data type name, okay? We are going to teach you in chapter 4, 5, 6, 7, 8, 9 about all of these, okay? Now I'm going to move on to the next one. Let me see how much time I have here. We still have some time, okay? These are by the notation. We have these 4 different types. The next one is called class. Okay, so that's called class. This one is compound 6, okay? So here we go into compound 6, okay? Compound 6, okay? Compound 6, we are going to teach you class. Okay, class, and we are going to talk about object. Okay. Number 1, let's actually look at what is class and what is object. This go back to the chapter 4 slides, okay? Okay, now we go into the chapter 4 slides, okay? So our chapter 4 actually on object and class, but I actually go into different data types so you know about these different things. So we go into the start to look at the chapter 4 slides, okay? And we preview different data type today, okay? This one is a class. We started to talk about class and object. First thing you must know is Python is a 100% object-oriented programming. So everything in Python is an object, okay? Everything in Python is an object. So everything in Python all have data type and all have function working on it, okay? And we need to understand the basic about computer graphics and also the object, okay? So each data type can be represented as a set of value and each has a set of operation associated with it. This is so-called objects, okay? Every data is object and each data type is called class. So class is data type. And object is data. Is that okay? Class is actually, so when we say actually what? Still hear me? Hello, still hear me?
Yeah.
Yeah, okay.
Yeah.
We just some signal a little bit, okay? Sorry for that. Hey, how come this guy's trouble again? Hear me?
Yup.
Yeah. Okay, so here let's see. So we say that actually I equals 3. I actually is a object. Okay, 3 actually is a value. And then integer is a class. It's a data type. Okay, it's actually data type is a class. Okay, so today we are going to talk about what is object and what is class, okay? And this is actually based on Python's definition. In Java, the definition is different, okay? So each object and class, okay? Object is the data, okay? So they are operations. So we will just actually give you some simple examples so you will know, okay? So here we are going to define a new class called this one called rectangle. Okay, this class that rectangle we will have define underline init, underline self, comma, x and y. Okay, let's put cx, comma, xy. Okay, let's don't call it xy, let's call it width and height. Okay, so self that cx equals cx. Okay, self that cy equals cy. Okay, self that width equals w, self that height equals h. Okay, that h define a class. And how can we do about this one? Okay, let's do this one. We have R1 equals rectangle 1.0, actually 10, 10. Here, let's do 100, 100. Okay. Okay, that's a rectangle. And then we do print R1. And we are in trouble, okay, because it cannot be printed. Yeah, you print you such things like, I don't know, I don't understand. It's saying that it's a rectangle object, okay? So let's declare a class called rectangle. So rectangle is a class, okay? So rectangle is a class, and the class is a data type. So we have rectangle class. It is a data type, and we generate a rectangle that's called R1, and this R1 center as 10, 10, 100, 100. Okay, make sense? Make sense or no? So here we say from graphics import start, right? Last time we worked out on this, right? So here we have this one. We print that one, and we do win equals graphic win of test. Okay, 600, 480. Okay, and we do rx equals rx1 equals actually rectangle. Okay, point one actually point. Actually, it should be 10, 10. Okay, instead of using 10, 10, we say R1's CX, R1's CY. Okay, comma, another point. We give them R1's CX plus R1's width, comma. Here I need to minus 1. Okay, so here I have R1 the CY plus R1 that height minus 1. Okay, that's R1, right? And we do say rectangle, we do RX1 that set field, let's set blue, okay? Okay, and we do RX1 that show win, and then do win that get mouse, and then win that close. Okay. Okay, that's wrong. Okay, that's wrong. Type it. Okay. Graphics. I have on HRS. Wrong again. Okay. No argument, missing argument WNH. Let me see, missing argument WNH. Rectangle W and H missing to require init missing to require position of W and H. Let me see. I have rectangle CX, CY, 10, 10, 100, 100. Let me see. Self that height, self that width. How comes that actually to require positional error? Point. R1 that height minus 1. Let me see, something wrong, okay? Here I have R1 that X plus R1 that width. One moment, okay? Sorry. Let me try different way, okay? So here, instead of directly using it, let me actually do this one, okay? Define, actually get width, okay? Self, okay? Here I return self that width, okay? And here define get height, self, okay? Return self that height, okay? So here this one should be R1 get width. This one should be R1 get height. So here I have the init rectangle underline init. Okay, should be fine. Let me try one more time, okay? It actually saying rectangle R.1 init missing to require positional arguments. Okay, how comes it missing? Do I spell wrong? Rectangle init 10, 10. So right here, let me print something, okay? Make sure we have everything. We need R1 that CX, okay? Print R1 that CY, okay? Print R1 that width. Okay, so you create a object called rectangle type, okay? Oh, I see. This one is a rectangle, so I'm not going to use rectangle. Let me change the name. It actually has the collision. So let me actually call the data as rec. Don't call it rectangle, okay? I'm sorry, I make a mistake by sharing the two names for a graphic and view, okay? So here actually invalid data type. Point. So rectangle. Let me try to bring up my menu, okay? A moment, okay? Don't worry. Sometimes I don't remember every single line of the. I don't remember everything. So let me bring up the menu, graphic menu, okay? So somehow, well, previous mistake is actually I share the same name for the rectangle and graphic wins rectangle, okay? Two share the same name, so actually it creates trouble. So now the second trouble, I haven't found what's wrong yet. But let me actually bring up the graphics, okay? I remember it's 2 point. Yeah, it should get 2 point, it should be fine. Okay, coming up, okay? So here, let me find Control F.
Dr. Chow, could you go back to the code or?
Yeah, one moment, okay. I'll be back, okay? Don't worry. Okay, I'm trying to find the rectangles. At this moment, the computer is slow. I'm not sure what's going on. Okay, here we have a rectangle. So the rectangle, let me see. Set field, set list different thing. Okay, one moment, okay? Actually, still loading the data. Okay, so 2 point, I get a rectangle. Yeah, actually it's by 2 point. Let me see what's wrong with my code right here. So I have 2 point, rectangle, point. Here actually I should have a print height, okay? Read on again. Okay, we got it, okay? So now let me keep on the code over here, okay? So the thing is, this class is, originally I used rectangle, is wrong because I already had the rectangle in my graphics, okay? So I changed to rect. So rect is actually, this kind of rect, we call it a data model, okay? This data model is used to keep track of the rectangle data. So this rectangle has 4 data: center of X, center of Y, C, X, C, Y, right? And your width and height. And actually my calculation is wrong. My calculation actually using this point, not using center. I'll change it, okay? I'll change it. Is that okay so far?
Yes, Dr. Chow, could you scroll down?
Yes.
Thank you.
So we create that rectangle. This is data, okay? This portion we call it view. View is actually, views a rectangle and the model's rectangle are different. Model's rectangle is keeping track of the numbers, the 10 and the 10, 10, 100, 100, that's stored in the model. View is to draw it. So view actually set at the point. So RS1 is the view rectangle. That's the one we see it on, that's the one we see it when we run it, okay? When we run it, we see this one on here. This one is the view rectangle. So view rectangle, this one is view rectangle, this one is the RS1, okay? And the data is a rectangle over here, and the data being used over here and here, okay? And here. Is that okay? So basically, behind this rectangle over here, we actually have the CX, CY as this point, and the width as this width, height as this height. And this is a data class. So this is a class is a data type, and we use that to create an object. So R1 is an object, a rectangle object, rect object, And Rx1 is a rectangle object. It's over here. Two are different things. One is for data. One is for view. View is for you to look at it on the graph. Is that okay so far? Is that okay so far?
Yes, could you wait 1 second?
Hi, Ethan, are you okay?
Yes.
Yes. So this, yeah.
So for the within, what is the smallest value you can type in?
Smallest number you can type in, I think it's 0 or 1, because your picture has 600 by 480, but you actually minimum is 1 pixel, right? Can you have 0 pixel or minus 1 pixel? No way, right?
Dr. Chow,
Yes.
It's not letting me. It's not showing up.
Not showing up right now.
Yeah, can I share my screen?
You mean your program doesn't show up correctly?
Yes.
Okay. No problem. Okay, one moment. Yeah, you share your screen. The rectangle changes the rect, RECT, because your data object and view object are the same name. Delete the angle. Yeah, up to here. And the class name also. The class name, go up, class name, go up, class rectangle. That one also delete the angle. These are data model, we actually can do it, okay? You have other problem, okay? You have other problem.
You just spelled Phil wrong.
Stop yelling, I got it.
Yeah, set. Yeah, no E.
Okay, thank you.
Got it?
Yep.
Okay.
Dr. Chow, mine isn't working either.
Yeah, you sure?
Okay.
You don't have get width. Number one, you don't have get width. You don't have get width. You have a few. You have a few error here. It should be a parenthesis, but you type a Y there, right here. Remember here. That should be a parenthesis, but you type a Y. No Y there, right? Delete the Y. Delete the Y. Second, here you need to have a defined get width, but you don't have. So change the line. DEF get width. Space get width. And then self. And then return width. Get width need to be one word. No, don't delete. It just delete the space. Yeah. Parenthesis self. Column and then return self dot width. Yeah. And also here the same thing. You make the same mistake I make. Here should be no angle. The name need to be different. Okay. The key point is that the name needs to be different from your rectangle RSO1 here. Wrong it. No argument. Go back. DEF init. DEF init. How comes you have no argument?
Did I do something wrong?
You need to import graphic. You do not import graphic. Hey, from graphics import start. First line of the program. Up, even up. First line of your file. Here is not first line. What is first line? Delete a few lines. That's actually too much. From graphics import start. Space. Graphics space import. Star. Star is a single star. No. Star. Shift A. Yeah, that one. There's a space between T and star. Yeah, wrong. Type error rec take no argument. Why your rec take no argument? Type error. Let me see. Go back to your program. Let me see. Go back to your program. Okay, let me check. Okay, let me check. Don't worry. One moment. So here you have defined rectangle. Over here, go up.
Right here, should it be rect?
No, I think the problem is here you need to have two underline. It's not single underline. It need to be double underline, not one underline. So then you have other problem, okay? Don't worry, other problem. Your is R1, you here it become RL. It's R1, it's not RL. Okay. So here is R1. We use R1 for this one. Is actually RXL is actually fine. Hey, don't move. That's R1. Yeah, this one R1 here. The other one you prefer RX1, that's actually fine. Delete. Hey, yeah. So here. Okay, wrong. You can wrong now. Wrong. Hello, Ella, you can wrong. Yeah, got it. But you did not set the color, okay? You set silver, yeah. Is that okay? Okay.
Yep.
Any other question?
No.
Ethan, you have question, Ethan?
No.
No. How about Zoe? You have question?
Not really.
We are not done with chapter 4 yet, right? Today I go over different data type and go over simple class. So you are not required to work on chapter 4 homework yet. So last week we worked on the Mickey Mouse or Smiley, right? You can send it to my email. Today, what would be the homework? Today's homework is actually, I give you a class. The class is actually rectangle, right? How about today your homework is a circle. That's called CIR because I don't want you to be in trouble with the graphic class. So that's called CIR. Is that okay? So do a data class CIR and also print it out. So you should have something like this over here. Is that okay? Make sense? So I work on a rectangle in class, right?
Mm-hmm.
And the homework is not repeating the rectangle. Homework is please work on a file similar to this one, but get a class circle and you have CXCY and maybe radius or something, okay? Here you have the C1 equal circle 1, given the same CXCY and radius, okay? And here you are going to put that data to create a view models circle and see if you enjoy it. Is that okay? So in class, we demonstrate the rectangle and homework is circle. Make sense? But you need to give me a class called CIR and also a view draw on the graph. Any question? Hello, any question? And
No.
If you are done, you can send to me, okay? Send to me by email or any question you are okay to let me know. I will help you, okay? Send me by Facebook message. I will check, okay? And maybe need Zoom. I will Zoom with you to find out what's wrong with your call, okay? Any question? Okay, if no question, we are up to here for today, okay? So today we go through different data type and also go over the class as well. And the homework will be a circle for data model circle and also the view model circle, okay? Okay, and bye now, okay? Good night.